Hi everybody, Patrick here from engineeringshot.com, paintballprops.com, and escaperoomelectronics.com. Today we're going to put together an Arduino PLAYBOT from scratch. We're going to install the LCD later, and we're also going to assemble a resistor-based keypad that comes with some reward tiers in the Kickstarter, which is linked below. So let's talk about the components. We have a single 100 ohm resistor, 51 ohm resistor, two 1k ohm resistors, a 2.7k ohm resistor, two 20 ohm resistors, 20k ohm resistors, and 5 10k ohm resistors. We've got a single 100k pot, potentiometer, variable resistor, 4 0.1 microfarad ceramic capacitors, an active buzzer, electret microphone, light sensor, light dependent resistor LDR, infrared receiver, 1N4001 diode, a 7805 5-volt regulator, whole bunch of various male pin headers, a single 10 microfarad electrolytic capacitor, two tactile momentary push buttons, two 2N2222 NPN transistors, infrared transmitter, two 100 microfarad electrolytic capacitors, 5-volt relay, a 3-pin terminal block, a single 4-pin female header, two 6-pin female headers, 8 M3 screws, two 18 picofarad ceramic capacitors, 4-pin dip switch, 3-pin dip switch, a 7-pin dip switch. Now the one you'll get with your kit will be a little bit different from this, but this is the only 7-pin dip switch that I have in stock currently. The rest of the parts are on the way. 4 M3 standoffs, and a 16 megahertz crystal oscillator. The LCD comes with a 16-pin rail already connected, so I'll be showing that when we install it later on in the video. And when we start to assemble the keypad, I'll introduce the parts for the keypad separately. So first things first, let's talk about the resistors. Your 10k ohm resistors are here, 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 and here. They're all labeled 10k. Your 20k ohm resistors are here and here. Just to the left of that, you have your single 100 ohm resistor labeled 100R. The 20k resistors are labeled 20k. Your 51 ohm resistor is placed right here, labeled 50R for 50 ohms. Your first 10k ohm resistor is right here, labeled your first 1k ohm resistor is right here, labeled 1k. The second 1k ohm resistor is right here, labeled 1k. And lastly, the 2.7k ohm resistor goes right here, and it's labeled 4K7, but that's an inaccuracy. Place your single 2.7k ohm resistor in this slot right here. Again, you might have some trouble seeing this from seeing the writing from this perspective, but when you have your printed circuit board right in front of you, it's very easy to read the indications on each of the resistors. Lastly, our variable resistor, our potentiometer. It only fits in one way. You don't have to push it all the way down in the board, just make sure that it's flat. Hold it down with one finger and solder the 3 pins on the other side of the board. So I'll solder those into place, and I'll show you what it all looks like before we solder in our capacitors. A quick edit. There is another 100 ohm resistor that I forgot to mention right here, labeled 100R. And there's also a third 2N2222 NPN transistor. T3, T2, and T1. In the case of the ceramic capacitors, the 0.11 microfarad ceramic capacitors and the 18 picofarad ceramic capacitors, the lead sizes are the same. There's no positive or negative, so you just have to make sure that they are soldered in the right places. The 10 microfarad electrolytic capacitor has a long lead and short lead. Long lead is positive, short lead is negative. In the case of the 100 microfarad electrolytic capacitors, again, long lead positive, short lead negative. So first things first, let's talk about where we will be soldering our 0.1 microfarad ceramic capacitors. There's a slot right here labeled 0.1U. There's another right here, 0.1U, U for micro. There's another right here, 0.1U, and another right here. As for the 18 picofarad capacitors, they go in these two slots labeled 18 It's actually labeled 18U, but they should be 18P. Doesn't matter, they're the physically smaller ceramic capacitors, and they go in those two slots. When you're soldering those two in, make sure they're flush to the board, and make sure that you don't perform any shorts, because those are two very important capacitors. They work with the crystal oscillator, which clocks the operation of the main chip. Now, the 10 microfarad electrolytic capacitor goes right here, labeled 10U, and there's a pin on the top from this perspective and a pin on the bottom, or rather a hole in the top, hole in the bottom. And there's a little tiny plus sign on the top hole. Make sure your long lead goes in the top hole from this perspective, short lead goes in the bottom hole. You reverse that and power up, your capacitor is going to blow up. So again, long lead in the top, short lead in the bottom. Now your first 100 microfarad electrolytic capacitor, same thing. There's a top hole from this perspective and a bottom hole. Top hole has a little plus sign beside it. So long lead in the top hole, short lead in the bottom hole. Now for our last 100 microfarad electrolytic capacitor, right here, 100U, it's labeled 100U. Little plus sign above the top hole. Place your long lead in the top hole, short lead in the bottom hole. Sorry ladies and gents, second edit. It's my first day. My wife and I just had our first baby, and like literally less than a week ago, so my brain is kind of mush right now. So I made a little mistake there. There are 5 0.1 microfarad ceramic capacitors here, 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 and here. As well, I forgot to mention, you don't have to do this, but it's nice to bend this electrolytic capacitor, the 100 microfarad electrolytic capacitor, over, because this is where the LCD is going to go, and it just gives the LCD more room to sit. So you don't have to do that. Good practice too if you can, if you remember to. If you've already soldered it, it's not a big deal. Okay, so next we're going to solder in our buttons, our transistors, and our diode. So the buttons are extremely easy. They only fit in one way. Line up all 4 holes for the 2 buttons here and here, the reset button and the cell button, select button. Line the leads up and push down. They should click into place, and when you solder them, solder one pin and then make sure that from the top view that they are flush to the printed circuit board, and then solder the rest of the pins, the remaining 3 pins. Do that for both of the buttons. The diode is also very easy, but you have to make sure that you place it the right way, or else your system will reset when the relay is activated. The single diode goes right here, D1, and what you'll notice, even if you can't see very well in the videos, there's a little white stripe facing the bottom hole, and that is to show that that is the negative side of the diode. Now the diode itself, again, might be hard to see right here, but there's a black side and there's a side with a little white stripe on it. So from this view, make sure that the lead with the white stripe on it is facing the bottom of the board, and that the black side of the diode is facing the top of the board. Make absolutely sure to solder that in the right way. So now we've got our 3 transistors. There's a flat side of the transistor. You'll see that this one is rocking on it right now. And then there's a flat side. The flat side is the face side, and that has the writing on it. And we're going to solder those into T3, T1, and the T2 slots. And making sure from a bird's eye view that the flat face side faces the flat face side on the footprints, and that the curved sides of the transistors face the curved sides on the footprint. So solder those into place, make sure that there are no shorts and that your solder joints are good, and next we will solder in all of our headers, both female and male. After this step, I suggest waiting until the next step so you can see how I've soldered everything in. This step is very easy, but it's a little time consuming, and you just have to make sure that you solder the right headers in the right area. So what I'm going to do is I'm going to zoom in a little bit in just a second. I've laid out the headers beside where they're going to be mounted. We've got a single 6-pin header right here, which goes in this slot. A single 3-pin header, which goes in this slot right here. 5-pin header goes right here. 4-pin header right here. 6-pin header up here. Another 6-pin header down here. 2 3-pin headers here and here. 2 4-pin headers here and here. The single 4-pin female header right here. 2 2-pin headers here and here. And lastly, the 2 6-pin female headers to the far left on this header and the far right on here. There should be 4 empty pins in the middle once you've soldered them into place. So make sure that this header is as far left as possible, this header is as far right as possible. Just to give you a better look. Male header, 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 4-pin female header, 2-pin male header, male header, 2-pin or 6-pin female header, female header. One more edit, unfortunately. I forgot to mention this 2-pin header right here. So there are 3 2-pin headers total. I'm going to solder that into place now, and next we're going to solder in our dip switches and our socket. Changing up the camera angle here a bit. The socket has a notch on the left-hand side. The footprint right here has a notch on the left-hand side. Just line it up. It should fall right into place. Once it's in, hold it down with one finger. Turn the board around, solder 1 pin, make sure that the socket is still flat, and then solder the rest of the pins. The 3 dip switches are pretty self-explanatory. The default switch settings are actually on the footprints of the board. Again, this 7-pin dip switch won't be the same dip switch as you will receive if you buy a kit of this. It'll be a little bit different, but you'll be able to determine which dip switch is which, obviously, because this is a 4-channel, this is a 3-channel, and this is a 7-channel. So 7-channel here, 3-channel here, and 4-channel here. Solder everything to place, double check for shorts. Now, watch the next few steps before you solder, just so that you can see how I've done it after the fact. This is the infrared transmitter LED and the infrared receiver. The infrared transmitter LED has a long lead and a short lead. The receiver just has 3 pins and a window on the front, a little infrared receiving window on the front. For the receiver, it goes right here. You want the receiving window to be facing the left side of the board. The back of this is just metal. Have the metal side facing the right side of the board. Again, you'll see how I soldered in just a minute. The transmitter LED goes right here, and there's two holes, top hole and bottom hole. Long lead in top hole, short lead in bottom hole. If you reverse that, your infrared transmitter will not transmit. So now let's go on to the microphone and the light dependent resistor. And the buzzer, I should add. The buzzer has a long lead and a short lead. And what you want to do is you want to place the long lead in B+ and the short lead in B-. If you reverse it, your buzzer will not work. The light-dependent resistor has 2 leads of equal length. There's no polarity. It is literally a variable resistor that changes its resistance based on light, and that goes in the LDR slot right here. I'd place the head of the LDR about 1 centimeter off the top of the board. As for the microphone, what we're going to do is solder it in right here, and you'll notice that there are 2 leads that are facing, from this perspective, the right side of the microphone. And you'll notice on the board, the MIC footprint, that there are 2 pins to the left. So what I'm going to do is, from a bird's eye view, I'm going to line it up so that the leads on the outside are facing the left here. So once you actually have this flush on the board, it should sit perfectly within this footprint circle. If you mount it the wrong way, it's going to interfere with the LDR and it's not going to work. So solder those components into place. Now we're going to look at the crystal oscillator, and then I'm going to zoom out after I've soldered everything into place just so you can mimic what I've done. The crystal oscillator fits nicely into this slot right here. There's no polarity, just make sure it's flat to the board, and solder both leads, both nice solder joints, making sure that nothing is shorting to any nearby component. There's my infrared transmitter and receiver. There's the crystal, the buzzer. You can remove this tag if you like, it's just an adhesive tag. And there's the light sensor just above the top of the microphone, and of course the microphone itself sitting nicely in that circle. This is a very easy step, and we're getting towards the end of the assembly of the PLAYBOT. This is the 5-volt relay. It has 5 pins. It only fits in one way. Make sure that it is that you solder each pin very carefully. 3 pins on the left, 1 pin on the right, or 2 pins on the right. Make sure that all 5 solder joints are strong. Be generous with the solder. And then you've got your 3-pin terminal block. There's a terminal side and a plastic side. Plastic side faces the relay, terminal side faces the right side of the board. Make sure it's flush. You can also be generous with the solder on the terminal block. This is the last soldering step for the PLAYBOT. The power jack only fits in one way. Make sure it's flush to the board, and that each of the 3 power pins gets enough solder. To ensure that you don't melt the component, what I like to do is I like to add a little bit of solder here. Once it's in place on the bottom of the board, I like to add a little bit of solder to each of the 3 pins, and then add to each of the 3 pins, just so that you distribute heat. If you've got a good quick soldering hand, do it however you'd like, but what I like to do again is just fit it down so it's flush to the board, hold it down with one finger, turn the board around, add a little bit of solder to one pin, and then add solder, add solder, add solder, add solder, add solder, add solder, until you're confident that it has a sufficient amount of solder on each pin without adding too much heat for too long on each of the 3 pins. This 7805 5-volt regulator goes in this slot right here. You'll notice that the footprint has a little white stripe on the right hand side. That's to indicate the back of the component. So what we want to do is we want to have the front of the component with the writing on it facing the right side of the board from this perspective, and we want to have the flat white side facing the left. So we're going to solder it in like this, but we're going to have it pushed down into the board a little bit. So I'm going to solder that into place, and I'm going to show you what it looks like. And there you have it. Now what you want to do is get ready for the LCD installation. As you can see, I've already installed 2 standoffs, but I haven't tightened them, so they're moving around a little bit. They're loose, and they're done like that for a reason. It makes it easier to mount the LCD. So what you want to do is take 4 screws from the bottom of the board and gently, sorry if this goes out of focus, place them all in, making sure they're all still a little bit loose. Do that with all 4. Okay, so we've got 4 standoffs, nice and loose. You don't have to do it this way, this is just how I like to do it. The LCD, it's got a 16-pin rail. Place the 16-pin rail in the 2 headers. Sorry if my camera went out of focus there. As you can see, there's 4 pins in the middle that aren't doing anything. That's expected. Now what we want to do is we want to line up our remaining 4 screws, screw in the top 4 holes, and then after we've done that, tighten the screws on the back. And then we've fully assembled our PLAYBOT. Next we just have to place our chip into the socket. Now I've got it completely assembled. I've just got my keypad connected. We'll assemble it. We'll talk about assembling a keypad in just a second. But I'm going to plug in power. Nothing comes up until I press a button. I press button 10. I'm going to press button 1. Hopefully you can see the LCD. It's a little hard to see with my camera, unfortunately. I'll just zoom in. But this is showing us that everything's working quite well. You press button 5, or you press number 5. So, our PLAYBOT is working. Go through the project videos at the end of this campaign. All of the code is fully commented for all of the projects, and all of that code and schematic diagrams, everything will go towards people who pledge towards the Kickstarter campaign, which is linked below. So now let's quickly talk about the keypad. We're not going to assemble a keypad piece by piece. Normally I would, but it's very simple, and I don't have any of the updated printed circuit boards. They're in transit right now. This is the final version of the keypad assembly. My first revision had the holes were too small, so I have some of those lying around, but none of the new versions. In any case, it's very simple. The LED button, or the buttons, only fit in one way. You just need to line up the holes, press it in, hold the button down, and solder from the other side. You just need to solder one pin, check that it's level and flush to the board, then solder the remaining 4 pins. But first things first, you'll want to solder the resistors. But before we do that, let me just show you. There's one component, a 3-pin header on the back of the board. It's very simple, just solder them like the headers on the PLAYBOT. You can do that last, it makes things a bit easier. And what we have for resistors, we've got a bunch of 2K2 resistors. I believe there's 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is a 100k ohm resistor. So what you'll get is you'll get 11 2.2k ohm resistors and one 100k ohm resistor. Simply solder them all into place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And your single 100k ohm resistor here. Once you're done that, mount your buttons. Solder each of them so that they are nice and level to the board. Lastly, take your 3-pin header, place the short ends through the back up through the top, and solder up here. It's very, very simple. It doesn't require much more explanation than that. So that is the assembly video. It was a little clumsy. I'm sorry about that. It's been a crazy week. My brain is mush. But I appreciate your patience. I hope you found this helpful. The Kickstarter is linked below. If you haven't checked out my channel, the first 11 project videos have been listed on my YouTube profile. So thanks again for watching and have a great day.